Good morning, everyone, and welcome to the IMAGIN Webinar Series. Believe it or not, it's already our 11th installment in the series since we started back in November. And I want to welcome you all to our presentation today. Today, we'll be hearing from Bryce Hall and Chuck Dostal from Nearmap on aerial imagery, a rapidly evolving technology for the future of small cities. My name is Thomas Van Bruggen. I'm the president of IMAGIN and your host today. And I have a few slides just to go through and kind of do some housekeeping and reminders for you. And then we'll hand it over to the guys from Nearmap. I want to thank our webinar series sponsors, Fishbeck, Giffords Webster, and BSNA Software. All of them have been longtime supporters of IMAGIN and continue to do so this year by sponsoring our webinar series. So we thank them and encourage you to check out their websites and their products that they can offer to enhance your GIS environment. Want to just make note of our next and last webinar that is in season 1 is what I've started to call it. We're wrapping up our first round of webinars on April 29th with Brian Wooden from the State of Michigan Land Bank Authority on Confessions of a Part 107 UAS pilot. And then a couple of announcements. We're going to be starting what's called a Geo Roundtable meeting. We're still working on the name. It might change names, but these will be virtual meetings where we're actually just going to open it up as a meeting instead of a webinar, where we can just have open discussions about a given topic. So next week, I believe it's Tuesday, we're working on getting out last minute communication on that, but Pete Schneider and I will be hosting the talk about distributed geodatabases and replication to follow up on his presentation from a couple of weeks ago. And it's not a presentation, it's an open question and answer roundtable discussion environment. So if you have questions about distributed geodatabases and replication, join us and look for that email coming later today or tomorrow for that for next week. And then season 2 of the IMAGIN Webinar Series will begin in May. We're collecting presentations right now. We've already got a few lined up for May. And we also would encourage you to please, if you have anything you'd like to share, get onto our website, go to the webinar series, and up at the top, there should be a link that allows you to fill out our geo form where you submit your abstracts. So we are building season 2 and we're gonna roll right into them, try to go without a break and just keep building these great educational webinars for you. A little bit of housekeeping, send your questions through the questions and chat box. All of us on the presentation side will be able to see those and we'll answer those, I believe, at the end. The webinar is being recorded, so I will get the video processed as soon as I can and post it within the next few days, as well as the slide deck. And then just a reminder to check out imagin.org for more information on our continuing webinar series. So with that, I'm going to hand it over to Bryce Hall as the presenter, and we'll get started.
I'm gonna go ahead and show my screen. Hopefully that's coming through okay.
It is, we can see that.
Perfect. Well, we appreciate you guys taking the time to meet with us today. We're excited to go through a few items of aerial imagery and how technology is rapidly changing, city assessments and the ability for, cities in general to grow and expand, through the use of technology. A little bit about Nearmap. We've been around since 2007. Been here in the US since 2014. We're headquartered in Australia globally, and here in the US, we're based out of South Jordan. How we proactively go out and capture imagery is we put camera systems in the belly of fixed-wing aircrafts, and we go capture based off of population. So we cover about just right around 75% of the US population areas, and we update those areas anywhere between 1 and 3 times a year. For the majority of our customers, they use our imagery as base layers integrated with third-party platforms like Esri, who we're a gold partner with and have been since roughly around 2017. And establishing a great relationship with those integrating partners is key for us. My name is Bryce. I work specifically with government entities. I've been with Nearmap for about 2 years. Chuck Dostal, he's oversees our solution engineer team, and I think he's going on a few years as well. And he'll do a little further introduction when I pass the time over to him. But what we are is in our captures, we focus on a few different aspects. Staying current is the ability to update the locations where we have our coverage areas multiple times a year. It provides the ability for multiple departments and multiple uses and areas. It provides a better planning, proactive rather than reactive planning. When we capture the imagery, our camera systems are patented camera systems and processing, producing a sub-3-inch resolution. And all of that imagery is then hosted in what we call our map browser, based in the cloud. One of the things that makes us most valuable and most helpful is the access to all of our historical imagery on a multi-year basis, and being able to see those quick changes, of a click of a mouse on the historical side of things. Developing areas, growth areas, brings a lot of value to be able to see how and when, where can we put additional changes, where should we start planning for future projects, and those multiple captures a year help provide that for quicker assessments and more up-to-date assessments. Let's see. With Nearmap, not just working specifically with the government though, capturing this imagery proactive, it provides us the ability to be more cost effective. We're selling to multiple industries, anything between insurance, government, architecture, engineers, construction, roofing, selling to all the different industries. There's a high value for imagery everywhere. So it's kind of a slam dunk for a lot of different entities. In our camera systems, we offer a variety of different captures, anything from our vertical imagery, which is your standard ortho photography, that straight down shot, being able to take those measurements, lines, areas, quick panning and zooming, all different angles, perspectives, in all 4 cardinal directions. As well provides an oblique imagery, and that's going to be extremely helpful for getting different vertical angles, vertical measurements, mosaic viewing, and helping provide a better perspective looking at property and real estate assessments. Our panorama is a mosaic stitching of the obliques, helping once again in all 4 cardinal directions to get a bird's eye view of what's happening on the ground. As well, what we have available through our captures is 3D, some machine learning, and other types of digital surface models that we'll dive into here in just a little bit. Very helpful being able to capture it all in one capture, and having it hosted and available within our customers' hands, anywhere between 15 and 30 business days. So very, very useful and helpful depending on the season, and very minimal change from between the time it's captured to the time that's released and being used in your hands. With that being said, I'm going to pass the time over to Chuck to dive in a little deeper on our technical side.
Okay, guys. Thank you, everybody, for joining today. Like Bryce said, my name is Chuck. It's nice to meet everybody. I've got a lot of really great stuff I want to show you guys today. So let me go ahead and start sharing my screen here. Okay, great. Okay, so let's start looking at some content here. So we've got our 2.2-inch ortho imagery, our 3-inch obliques, and then we've got our patented measuring tools on our obliques where you can get measurements accurate to within 6 inches. We've got our 3D textured mesh where you can do things like a view shed analysis. You can also do emergency response and spatial analysis with that 3D. And then we've got our digital surface model and our bare earth digital elevation model. And then all these products kind of come together into a great stack where you can do a lot of different analysis with it, including with the AI. And I'm going to go into a lot of that in great detail here coming up. So really quickly, since we've been looking at a lot of slides, I'm going to show you a really brief video that kind of shows what our map browser interface is like. So this is our web-based mapping application where all of our customers have access to this, and it's a really lightweight application that people can come into if they're unfamiliar with imagery or GIS. They can come in and export images, do easy measurements, see historical imagery, overlay KML files and the like, and then also view our panorama and oblique imagery. And these are the obliques here. So we're switching between all the different images that our camera takes because it operates in a sweeping motion, taking images from 0, 15, 30, and 45 degrees. We make all those images available to the customer so that they can select from different images in the event that there's a tree blocking it or something. You can kind of see around obstacles. And then you can see how close you can get into the imagery and the resolution on it. On the obliques, this is all 3-inch resolution. And these measurements are going to be accurate to within 6 inches on the obliques, and they'll be accurate to within 4.4 inches on the orthos. So very, very accurate imagery with a lot of functionality built into this. And you've also got our 3D inside of here as well, but I'm not going to show much of that because we will touch on that in a live demo. But the real value of our imagery is when you can bring it into your applications and start using it in the environments that you're used to using it in. So this is inside of ArcMap, as a lot of you are probably familiar with. We do have a custom timeline add-in right here. You can see that we're cycling between the different dates. And you can access the historical imagery through all of the Esri applications. And really in any application that supports WMS, which is most applications at this point. And our new WMS has the ability to geofence areas and provide historical imagery, as well as deliver the imagery in 983 state plane coordinate system. We also integrate a lot of our other content with Esri, including our obliques. We have an oblique widget that we developed for Esri that's an add-on that you can put into your organization where you can access the measurable obliques inside a web app builder. This is a view of our ortho imagery inside a web app builder. This is a City of Sioux Falls public-facing application. It's another shot of City of Sioux Falls public-facing application. So we have the options for local governments to display our imagery to the public, and we also offer offline copies as well. This is our imagery 2D and 3D view inside of GeoCortex. So we partner with a lot of different vendors, and some of those are specific to local government, like CityWorks, GeoCortex, ViewWorks, and many others as well. So here's another shot of ViewWorks. This is another custom integration that we have with them. And again, this is Sioux Falls. Now, we also have a partnership that we're doing with Esri for their ArcGIS Urban product. So cities that sign up for ArcGIS Urban have an option to also get some Nearmap 3D with that. And ArcGIS Urban is a great new tool for city planning and management where you can ingest 3D and a lot of your other data as well. Now let's go through a couple case studies really quickly. So Shelby County, they use our imagery for their 911 dispatch, and they're a fast-growing county. They had a lot of issues with their address database being up to date. So they didn't have the right geocoding in place for some of these new neighborhoods, and their imagery was really outdated. So with Nearmap imagery, they were able to actually geolocate all these properties and update their address database, making their dispatchers more effective. And Timothy Zimmer, their GIS admin, he just really likes how it integrates into their whole product stack. You know, having the ability to integrate the imagery into the solutions that they're already using is one of the things that we hear most from customers as being one of the biggest selling points, is how it's so easy to set up and get it going inside of their systems. Another good example of using our imagery at a very, very large scale is the city of Chicago. So they receive a lot of 911 calls every day, over 10,000, and all of those calls are routed with Nearmap imagery. So they stream our imagery through our WMS API, and you can see that on their screen right there. That's actually one of the city of Chicago's dispatchers. The City of Boston Emergency Management is another one that uses our imagery a lot, including our 3D. They'll use it for things like the Boston Marathon planning. And in this example, they shared with us, they were able to get a lot of value from one of our recent flights last spring, right after COVID happened, to distribute COVID PPE. And this is also City of Boston, so they integrate it with their Esri dashboards, and they have a live feed of our imagery with their traffic incidents and dispatch information. So integrating this inside of your dashboards gives you increased situational awareness, obviously. It also gives you access to more relevant detail and in more detail as well. A lot of the sources that people access for this type of application are low resolution and out of date. You know, having current imagery in an emergency response situation is quite critical. We do have a lot of customer stories on our website. I'd encourage you guys to go check those out if you're interested in more. We have stories from local government to insurance and AEC, and a lot of areas in between. All right, so now I want to show you guys an actual live demo of some of our stuff. So let me pull up my browser here. So this is our map browser. Obviously, we've got Ford Field here, but quickly just show you a few things that you did see in the video, but I'll just highlight again. You've got all the historical imagery over here. These are different forms of content here. So you got vertical. Our panorama is a stitched together mosaic of our obliques. And the obliques are a single image frame. So you can see how it's oriented like this. Over here on the left, you can select from different images from those different angles like I was talking about. And measurements on these will be accurate to within 6 inches, as I said. But as you notice, it's just that single image chip. So that's what our panorama does. It actually stitches together all those images into a seamless mosaic where you can pan around, zoom in, zoom out. Can't do measurements on this though, but that's what the obliques are for. We've also got 3D inside of here. So this is all streaming through cesium tiles, and you can export this through Map Browser as well. It works really, really well. So we've got some, they seem pretty basic, but some really neat tools built in here. So I'm gonna click on this line. You'll notice that on this smokestack building here, I've got a little cursor and it's conforming to the surface of that 3D. So I can really see where I'm at in space. And I'm gonna click on the street next to this building, and I'm gonna go up to the top of the smokestack. And I can tell when I'm at the top because I'm getting that visual confirmation. And double click here. And now it's gonna give me the line length of 280 feet. But the relative height is 248. So we do the geometry for you to get the measurements off of those objects. You don't have to find the exact base, which is really nice. We also have area measurement tools in here as well. Now, the next thing I want to show you guys, which is really exciting, is our artificial intelligence. So this is pretty new. We've been working on it for a few years. So it's difficult for me to say it's new because I've been excited about it for literally years, but now it's ready for prime time. So we're in a very unique position where we can do artificial intelligence really, really well because we have a very large library of data and pixels, and those pixels are captured under various conditions in different countries and states and continents, different seasonality. So all that makes our algorithms much, much better. And all of it is also performed on just our imagery. So it's all performed on sub 3-inch resolution. And that consistent resolution also increases the accuracy of the results, because a lot of artificial intelligence is derived from multiple sources, like satellite, aerial imagery, drones. You've got a mixture of resolutions that you're looking at, which can really affect the results that come out of this. Now, one thing that's really neat here I want to point out is this is the trees, so high tree layer or high vegetation layer, which those are over here on the left. You can see we've got medium and high vegetation turned on. But what's interesting is this is a leaf off capture, and you can still see that these trees here still capture that whole canopy even though it's a leaf off. So that's part of the wizardry that's built into our artificial intelligence. Since we capture a lot of these areas leaf on and leaf off, we have the ability to extract insights even when things aren't necessarily there. Now, one really great place is right next to this with all these interesting building outlines. So let's zoom in and look at how crisp some of these are. So as we zoom in, you'll see that there's some transparency around these edges. And that transparency is indicative of our confidence. So we're very transparent about our confidence. So you can see how accurate those are. And then you can actually download a lot of this content and bring it into your GIS applications or whatever it is and extract some real insights from it. And it comes in a little bit different format as well. And I'll show some of that in a second. But these are all of the layers that we have over here on the left. So you've got a lot of different options. Now, everything from tree overhang all the way down through these surfaces, these are all vectorized outputs. So we have these available in point, line, and polygon format. So you don't have to deal with a raster. Now, the rest of these from LP cylinders down, those are all in a beta phase, and it's not because of the quality, it's just because they're in a raster format. So we could deliver these as a GeoTIFF, but they wouldn't be vectorized yet. And this list just continues to grow and grow because, if there's something in the imagery that you're interested in and a human can consistently and accurately identify what that is, then we can train our bots to do that as well, which is really, really exciting. So a lot of these have actually been requests from customers that we've started to train our models on, and eventually in a couple iterations of going through that, they'll be at a good enough quality where we'll start to vectorize them. Okay, last thing real quick, this is some of our beta stuff here. So this is power lines and power poles, and we actually vectorize the power poles as well. You can see we've got the ability to turn down the background, so you can really make some of these layers kind of pop out. And you can also change the symbology on them as well. So if I want to change the color of the lines, I could do that. You see, all this is captured at a really, really large scale. And even the power poles are, we pick those up really, really well. Even when there's occlusions from trees, or you've got blockage on it, we can pick up where the shadow is, and we also use that to identify where the base of the pole is. And now we're adding more information to these, identifying whether it's a power pole or a light pole, and there'll be a lot of other things coming in the future as well, which is really, really exciting. So now I want to show back to the PowerPoint here. Actually, there's one last thing I want to show you, which was the ability to export, which is important. So we have all these different export options. All this is available through API as well. The imagery and the AI is available through an API now. The 3D still download, but you have access to download a lot of different content here. And like I could do 20 square miles at a time in the 3D, and I could either draw a polygon or just upload an area. And then we've got all the different coordinate systems, including different vertical datums in here. So you can do 983 state plane US feet with NAVD 88 US feet, which is a pretty popular option for local government. Now this is what's really great, is that you can select a lot of different content. So on textured mesh, we have all these different formats. OBJ is great for Autodesk and a lot of other applications. FBX is good for Autodesk as well. It also goes into City Engine. SLPK is specific to Esri. So that goes into ArcGIS Pro, ArcGIS Online, a lot of other applications. FreeMX is for Bentley. So that works in like MicroStation, open roads, open cities, context capture. And Cesium is an open source format. That's actually what we stream in through our map browser. But you can select all these, and that just counts as one format. And then you can select 3 more out of these. So we could do point cloud, our digital surface model, and a digital elevation model if we wanted. Now, point cloud is derived from photogrammetry. It's got RGB values. It's 44 points per square meter, so it's very dense. The DSM and DEM are both 6-inch resolution. So the DSM is an elevation model where every pixel has an XYZ, and it has everything that's on the surface, including trees, cars, anything like that. The DEM is bare earth, so that removes all those different things. And it's kind of important for this next step because we actually use all these different forms of content together to come to some insights here. So let's go back to our PowerPoint here. This is some of that vector AI that's extracted from Map Browser, and you can see how the building outlines are different than they appeared inside of Map Browser. That's because these are vectors, and we were displaying rasters in Map Browser so that we could show that transparency for our confidence. And here's some of those confidence levels as well. So all this is in the attribute table. As I said, we're very transparent about our results. Also in this attribute table, if you were to scroll over, there's a link directly to Map Browser to the exact property and date that the results were derived from, so you can verify that without having to jump through hoops. And this is just another shot of what some of that AI looks like inside of Map Browser. Got some just really neat visualization tools that I like. All right, so now the fun stuff here, and we'll have plenty of time for questions here at the end of this. But this is some stuff that I've derived from our artificial intelligence, our digital surface model, digital elevation model, textured mesh, and point cloud. Not all from those products, but a mix-up of all those different ones. So let's see what's possible and how we got to this point. So this is our end state. So how did we get there? So starting, these are the building outlines that come inside of ArcGIS Pro through the Living Atlas. This is the imagery that comes by default inside of Living Atlas through Esri. Now these are our building outlines overlaid on top of the ones that, that Esri has. Okay, now we've got our imagery overlaid on top of those. So that's our 2.2-inch ortho and then our building outlines. Okay, so the next step is to load in the digital surface model, and then we've got the basically that surface information from that roof. So now we've just got to extract it. And the way that we do that is bring in the elevation model as well, the bare earth, and then subtract the DSM, subtract the DEM from the DSM. And what we're left with is a normalized DSM. So that normalized DSM basically just shows everything that's above the surface, and it shows its surface heights accurately. So taking that normalized DSM, flip that to the AI building outline layer, and we're left with a basically a DSM of the building itself. From there, you can run some tools to extract the roof shape, so like hip, gable, turret, flat, etc. Next step would be to extract the roof surface. So you're doing this using some raster functions and calculating that surface. And all these are saved as outputs that we'll use later to construct some of the content that I showed you at the beginning. So now we've extruded these LOD1 buildings. So these are basically just our building footprints extruded to the correct height, to the correct ground to peak height. But there's no roof shape. They're just a block. So that'd be an LOD1 type of scene. But then we can run some other tools to segment the roof into different parts. So we can figure out where the roof eave is. And you'll see that these kind of slope up and down. That's because they're on our digital terrain model, but it'll flatten this out. You'll see that it won't be sloped in the next step. So there we've extracted the building roofs and the exteriors and then fused them back together into a LOD2 3D building. And this wireframe is so you can see what the original was. So it extruded from the ground all the way to the top. And now we basically just removed all the excess to make give the roof some shape. Okay, and just for accuracy check, overlaid it on top of our 3D textured mesh. It's not perfect, obviously. It doesn't catch all of the details of the roof, but it is pretty darn close. I'm very impressed with how well this ran for an automated tool. And now just showing off a little bit. This was a leaf off capture. So the trees don't populate really well in leaf off captures in 3D. They tend to get missed. They'll be flattened, as you kind of saw in some of those last screenshots. We don't have a whole lot of elevation on those trees. They're flattened because there's no leaves on them. So the photogrammetry can't pick up those individual branches very well. But we also have a leaf on 3D capture. So I took our AI results for our high vegetation for our leaf off, overlaid those on top of a leaf on 3D capture, and then clipped it to that. And what we're left with is just the 3D trees, the 3D textured mesh trees from a leaf on capture, but they're the same volume as what the leaf off trees actually are. So that's great for doing like line of sight analysis on a leaf off capture, you know, for a signal propagation or even shadow analysis, things like that, wildfire analysis as well. Okay, and then basically taking out the textured mesh and just using the LOD2 buildings, the textured mesh trees, and that imagery now, because the imagery is higher resolution, so it's that 2.2 inch, so it comes through crisper then. Now just labeling this with just a fraction of some of the attributes that are inside of the attribute table from these AI outputs. So we've got the building height in meters, the eave height, and that's from ground to eave. And then this is symbolized by a number of stories, which are interpolated. And then also labeling it with the roof form shape. And this is actually the point cloud trees. So kind of similar thing, just extracted from our LAS as opposed to the textured mesh. So you can see how dense that point cloud is because it almost looks just like the textured mesh. Okay, and just really quick before we do our thank yous, just want to show you kind of the live version of this. This is inside of ArcGIS Pro. And that area that we were looking at, it's actually right over here. So you can see that it's actually a working model, and I'll just let it load here for a second. But this is all at a very large scale. So all these, all of the buildings were done automatically at, again, very, very large scale. And this one also has a flooding analysis in it as well. So if we zoom into some of these buildings, you can see we've got some animated water. Let that load. Works really great with our trees as well that we've extracted. So you can start to get insights on all the properties that are affected as well. So you can run an intersection analysis, which we've actually done here as well, but I won't show that. But yeah, these are great things you can do inside of ArcGIS Pro. This is not with any of our 3D turned on at all. This is just those 3D buildings. And then uploaded that to ArcGIS Online. So now this is a a streaming web scene that anybody can access. This one's not open to the public yet, but I will be publishing it to where anybody can access it. And yeah, so you could do those types of analysis and then bring them into applications like this. If you're doing it for, let's say an actual flood emergency response, you could whip this together, load it up into ArcGIS Online, and your people in the field wouldn't have to download anything. They could access this on their phones, their tablets, their laptops, and everybody can be on the same page and in communication with each other. So with that, that will be the thank you stopping point. And stop sharing my screen and thank you all. See if you got any questions.
Thank you, guys. There are a few questions that have come in, and so I'll go ahead and share those out, and we can go from there. So actually, Pete asked a few questions, asking about leaf on versus leaf off percentage, and if a flight is contracted to have a leaf off, is there a contractually stated leaf on or leaf off percentage that Nearmap meets? And if so, what is that percentage?
Good question. Sorry about that. That's a very good question. So most of the areas that we capture, we're capturing multiple times per year. And if it's an area that has a leaf on and leaf off season, we're typically capturing those twice a year, leaf on and leaf off. Now, some areas we don't capture but once per year. Our smallest metros are only one per year capture. So those will sometimes have leaf on, sometimes leaf off. Basically, the way that our capture system works is we fly proactively. So we have a schedule that we kind of adhere to, and with being a nationwide capture, we've got a lot of planes that we're moving around the country, chasing sun angle and good weather. So we typically capture those areas around the same time every year, not on the same exact date, but same time frame. Now, if you have requirements for leaf on or leaf off, we work with our customers all the time to make sure that we're capturing that during the time that you need it. So we can definitely work with you on that and make sure that we're capturing it during the seasonality that you guys need.
Great. Another question is, do you offer multiple resolution flights? For example, 3-inch resolution in urban areas, 6-inch in rural areas? Most often done for some cost savings a little bit.
Yeah, I can answer that one as well. That is a pretty standard way to cut costs, but we don't capture like that. I think you'll find that if we do need to do a custom capture for you, if we don't cover your entire area, we do custom flights. Those can be small extensions if there's a new area that is just outside of our coverage, or your whole county, we can also capture that as well. So we don't do the multiple resolutions because everybody has access to that imagery, and we want our imagery to be very consistent. Like I was talking about with the AI as well, having that consistent imagery is really one of the things that sets us apart. So even doing an entire county, for a custom flight at 3-inch, I think you'll probably find that it's more cost effective than a custom flight from another provider at various checkerboard resolutions.
Okay. Then a question about security. Oftentimes government organizations must adhere to FIPS security compliance. Do your feature services work with the SHA 256 FIPS algorithm?
Well, Pete, I don't know the answer to that off the top of my head. I'm gonna have to get back to you on that one, but I'm gonna grab a little screenshot of it really quick, and I'll make sure to find out and get back to you there.
Yeah, quite a technical question on that one. So I had a question too. Do you have a spot on your website where viewers, anybody that goes to your website can find out what coverage areas you've already done for Michigan? Like, for example, if we're looking, have you covered my county, Muskegon County, for example? If I haven't looked already, is there a spot on your website where we can do that?
Yeah, absolutely. You just go to nearmap.com, and right at the top, there's a coverage ribbon. Just click on that, and you'll be brought to a coverage map that's kind of embedded in the website. But if you also search on ArcGIS Online for Nearmap US 2020 coverage, you'll find a different coverage map, slightly same content, just looks slightly different. So those are two different ways that you can find our coverage. And if you have specific questions, like you want to run a coverage analysis, you can reach out to us and we'd be happy to provide some coverage shape files, some AOI files.
Sounds good. And then not a question, but Magdalena DeFranco says they've been using Nearmap for the past 3 years and now have access to the oblique imagery as well. It's been a great experience and all the users really enjoy having 3 captures a year. Very useful to multiple departments, and thanks for the presentation. So thank you, Magdalena, for sharing that as well.
Yeah, we appreciate that. And we did not pay him to say that, I promise.
Yeah. That is all of the questions that I am currently seeing. So I will, oh, one more came in. How many features are being digitized? You indicated utility poles, but are you picking up manholes and catch basin covers?
Yeah, so catch basins is one that we're just looking into, actually. We've been working with some traffic engineers, and catch basins is one that's of interest. Manholes is also one that we're already capturing. It's just not vectorized yet. So that one will be coming very, very soon. One of the things that comes up with, identifying features like that as part of our AI subset is the definition of it. So with manholes in particular, we've talked with several cities about what they consider to be a manhole, and it's not as straightforward as you might think, because some of them include drains on the side of the curbs, other kind of drainage. It's square, not the round manholes that you'd see in the street. So some of those definitions are what drive some of the attributes that we capture and how we capture them for our AI. But that one is absolutely coming, as well as some other ones like road markings and striping, curb lines, sidewalks, things like that. Those are all things that we'll eventually be segmenting out of the attributes that we're already capturing.
Wonderful. Well, again, that brings us to the end of the questions. So I want to thank you both for presenting today. A lot of great information and being able to see your product in action and see what you're offering, and some great technology. So thank you very much. Want to also just remind everybody that we do have another webinar series on April 29th for the State of Michigan Land Bank, Confessions of a Part 107 UAS Pilot. And so look for additional information on season 2 coming of the webinar series to begin in May. And with that, I thank you all for attending, and we'll get these recordings posted up soon. And with that, be safe and have a great day. Thank you.